some of these circuits finish building in the first 2 seconds. Some of them take 20 seconds to finish building. If you actually try using a circuit that took 20 seconds to finish building, it's going to suck. It's going to have horrible other properties, latency properties, throughputs. There's a reason why it took 20 seconds to build. So what we should do is we should throw that away. We should say, if it takes more than 5 seconds to build, I don't want it. I never want to use it. Throw it away. And that's great, except what about the people in Iran on modems, or the people in Cuba on modems, or the people in Zimbabwe on satellite phones over modems, or stuff like that? Those people, if we have a fixed 5-second timeout, then they're going to wait 5 seconds, because that's how much it takes for them to get a packet onto the internet. And then it's going to say, ooh, 5 seconds, that's too much. I don't want that circuit. So what we really want is some sort of adaptive timeout where we look at how long it's taken you to build circuits in the past. And if your average is 10 seconds, then we cut it off after 15. And if your average is 2 seconds, then we cut it off after 5. And we're heading towards being able to do that. The next step is actually teaching the clients to collect their own data set of what circuit timeouts they've seen. And then we need to do the same sort of thing for stream timeouts. Right now, if I ask for Google.com, I'm going to ask one circuit, and if 10 seconds pass and I haven't gotten an answer, I haven't gotten any sort of response, then I say, well, I guess something went wrong with that circuit. I'm going to switch to a new one, and I'm going to have a new 10-second period for that. And if I get no answer there, I say, well, I don't want that circuit either. I'm going to switch to this and have a 15-second timeout. So we've got the same problem there, where we've got a fixed timeout that is both too long and too short. So even if the fellow in Iran is really patient and he really wants to get his Twitter out and he's willing to sit there for 10 minutes, his Tor is not willing to sit there for 10 minutes. His Tor says, oop, 15 seconds, clearly too long. So that's something that we really need to fix for people all around the world. Okay, and how much time do I have? Okay, sounds good. So there are a bunch of other things that we could talk about. We've been fixing performance problems with the Tor directory system a lot lately. So there are a bunch of things that the directory is supposed to provide. There are a bunch of different conflicting goals. One of them is we really want every client to learn all about the nodes in the network really fast. As soon as a relay shows up, we want all the clients to be able to use it. Because there are a lot of, especially in Germany and China, there are a lot of people on dynamic IP addresses, and that means every day you get a new IP address. So as soon as you've got a new IP address, it would be great to put you into the list so you can get used. At the same time, we really want every client to have exactly the same view of the network as every other client. Because if you're the only guy who knows about this new relay, and then somebody uses this new relay, it's pretty clear who it was. So we really need large anonymity sets so everybody gets to choose their paths based on the same information. And at the same time, we really want it to scale up to thousands of relays or tens of thousands of relays. So once upon a time, when we had no users, we just had the version 1 directory design. You put all of the descriptors for all the servers in one huge file, and everybody fetches that file every 10 minutes. And it's not that big because there are only 10 relays. That turned out not to scale for all sorts of reasons. So the much better design is we publish what's called a network status consensus, where we publish tiny little summaries of each relay, saying here's his IP address, here's a hash of the identity key, here's what ports he's listening on, here's the bandwidth value that you should use for weighting your choices. And our goal is to actually, so in the version 3 design, the stuff that's out right now, the one that your Tor client is using, there are 2 components to the directory. The first component is this network status consensus. And then the second component is all of the descriptors. So you go out and you fetch your 150 kilobyte file, and then you fetch your 2 megabyte blob of descriptors. The next designs we're working on are throwing away that second component. There's no reason for you to fetch all of these huge descriptors with the keys and the exit policies and the contact information and so on. We should somehow figure out how to summarize that really compactly, either in the network status consensus, so every time you fetch a new consensus, you learn everything you need to know in order to pick paths, and in what we call a microdescriptor, which just has your long-term keys and your long-term exit policies and other stuff that won't change for a really long time. So I'd be happy to chat more about that later on if you're interested. So there are a couple of different results from this that we need to start pondering more. How do we figure out for a given design, is it actually going to help things? Is it going to make things better or worse? Our current strategy is, let's think really, really, really hard, and then deploy it to 300,000 people, wait a year for everybody to upgrade, and see if we chose the correct strategy. That works okay, but it's kind of slow, and sometimes we're wrong. Wouldn't it be nice if we had a Tor network simulator? Wouldn't it be nice if somebody could actually simulate enough of the Tor protocol in order to figure out that if you raise this parameter, then everything's going to get faster, or no, you're wrong, it's all going to get slower. Doing measurements is a really good start. All the graphs that you've seen so far are from Karsten, and he's hopefully going to produce a lot more. We've got data. Archive.torproject.org will show you all of the directory information since 2004. It's something like 27 gigabytes. You can fetch it and do whatever computation you like. And then the last thing to think about, every time I'm working on making the Tor network faster, I'm thinking about how do I make it more efficient? How do I make the path selection less random? How do I make it more directly going from the user to the exit relay to the destination? And anonymity, in some sense, is the opposite of efficiency. So the more anonymous it is, the less efficient it is. And that's not a hard and fast rule. We need to figure out ways to get both efficiency and anonymity. But every time I'm messing with any of these things, I have to start saying, what am I going to do for breaking anonymity for the users? So it's really tricky. There are a lot of systems people out there who say, oh, you just build a network backplane that tells everybody everything that's going on, and then you can optimize it. And that's great if you're a systems person, but if you're trying to build an anonymity network, then you can't use most of the tricks that they have. So those are a bunch of different ideas. I'll be around for the next few days to chat about it more, and I think I've got a little bit of time for questions. Thank you. And I actually have a last slide here also, a bonus slide for the number of users that we saw over the course of June in both Iran and China. So just at the beginning of June, we rolled out our stats for how to safely learn about what's going on in the Tor network. And so we've got this baseline of 500 people a day in June until suddenly it spikes up to 8,000 people a day. And this was pretty cool results in terms of getting a lot of people to notice what's going on in Iran and a lot of people to realize that they need ways to get around their firewall. At the same time, China was doing its green dam thing during this period, and this was the point where they decided, hey, let's block Google Search and Google Calendar and Gmail for 2 days. That'll show them. And it did show them. A lot of people in China started thinking, wait a minute, I thought my government was keeping me safe, but they can do that? I'm not sure I like this firewall thing anymore. So there's a lot more we can talk about censorship in an hour in that tent, I believe. Questions? We need a mic over here.
Oh, yeah, no.
There you go.
So we have 5 minutes. So any questions?
There are 2 people with hands up.
Just one question. There's been this court case in Holland against the Pirate Bay, where the judge is basically saying to the Pirate Bay they have to block IP addresses from the Netherlands, and it's not clear how it's going to work out and if they will have to comply and how they will comply and when. But theoretically that could mean that an enormous amount of Dutch users